all the features of these two engine blocks are finished. The easy ones are, of course, to see are the main bearing hole, cylinder, head bolts, the valve body hole. The important one that's a little tougher to see is the port that allows steam to go from the valve into the cylinder. And to create that, you have to drill a hole all the way through there like this. Of course, in operation, this would let the steam out, so I tapped it, and I'll put a 1032 set screw in there, a Loctite, a 1032 set screw in there to plug that up. Here is the steam in port. So steam will go in here, the valve will let it into the cylinder, and it'll push the piston down. I believe the next thing I'm going to do is create the heads. Okay, a word about building the head. Not on that, on this. What I like to do is build it too big on the three sides that are exposed here. Well, all four sides are exposed, but on the three sides that overlap. So you might be able to tell that there's a 1/16 of an inch or so there and a 1/16 of an inch or so here. It doesn't make any difference how much it is, obviously. I'll chop this off and leave, more or less this much. And then I'll, with the head bolted down, I'll take it off to chop this off, of course. But then with the head, I'll bolt it back down, and then I'll stick it on the mill and make everything flat, everything nice and smooth there, just like it was made that way, including this side. And then this side, I might, that looks pretty good. I might probably leave that like it is. So building these heads are a little tougher than it looks, especially if you decide to put 8 screws in it like I do. I like the square head better than the round head, but there's nothing wrong with the round head. With the round head you can put 4 or 6 in it and it looks pretty good. But I like the square head. So, and 8 screws I think looks a lot better than, say, where's my test piece? Here. I like 8 screws better than 4 screws. This is the first engine, slide valve, spool valve engine I built. It works fine, but I leave it laying around as something to take measurements off of, whatever. But I like 8 screws. Okay, the problem with 8 screws is that one of them, this one right here, sits right on top of the inter-cylinder valve steam port. Sits right on top of that steam port. So it's almost impossible to, for me anyway, to drill a hole less than 2/100 of an inch deep and then tap it. And that's what you have to do with this screw. I always wind up drilling completely through down into the steam port. So I usually plug that up with JB Weld or something, or actually Loctite would work just fine on these low pressure engines. And I run it that way. However, a person could just not even drill drill the hole in the engine block for the 8th head bolt. if we want to call this one the 8th one. A person could just drill the clearance hole in the head and make a real short screw and glue it in there. I think that's what I might do in the future. Or you might decide just to have 7 head bolts, which will work just fine. Oh, there goes the doorbell. Got the second head built. Of course, what I'm going to do is split them off. I put them all on this one piece of, both of them on this one piece of stock. Then I will separate them with a slitting saw, because I don't have a band saw that I can clamp that in. I've got my, oh, hold a minute, I guess I do. I've got my little 1/2-inch saw. That might do it. Definitely I can't clamp it in my 1-inch saw. So I'll split them apart and then clean them up on the mill, clean the sides up so that they are congruent with the 3 sides of the engine block. I'm truing up the sides, the overlapping sides of the head with the surfaces of the engine block. Maybe this makes sense now. What I've done is I know where 0 is there with my DRO, and I know that after I've already taken 1 pass, I'm 15 thousandths high still on the head. So I'll take 12 or 13 thousandths off and see what it looks like, because I'm not totally confident in my DRO. And then I will flip it and do the same thing, and then turn it another 90 degrees and do this side. I've got the head trued up to the 3 sides of the block. Well, I guess you can detect that one. You can detect it. But they're good. And I've got this head bolt in that's right over the inner valve cylinder steam port, but it really is just for looks. It's probably not in more than 1.5 threads. And it doesn't really, it's not going to hold anything. And I'm never going to tighten it down, of course. So I'll do the other one. You can see where I've got a lot to trim off there. If I hold it right, there you go. Not so much there, quite a bit there. And I'll make the top look pretty. Then I'll take a look at the bottom. It might, if it's scratched up, I'll give it a skim. So things are going along nicely. After I do the other head, I'm going to build the main bearing out of this 1/2-inch piece of bronze 932. I'll turn it to fit. You know, that's not a 1/2 inch. I think it's a little over that. It was probably sold as a 1/2 inch, and it I think is a 32nd over or so, which is good. I'll turn it down to fit. I'm going to build the main bearings for these 2 engines next. Main bearings go right there. I'm going to use this piece of 932 bronze for the main bearing stop. The main bearings are roughly half an inch diameter. Now, I'll have to mic it to find out for sure. And this, the width of the pedestal here, this width right here, is roughly half an inch, a little bit more probably. And my goal is to build the main bearings such that they stick out on this side and stick out on this side about 20 thousandths of an inch each. And that way both the crank disc and the eccentric can bear upon those main bearing protrusions outside the width of this. If the main shaft should slip back and forth like that, I don't expect that to happen. But if they should, then instead of bearing on the aluminum pedestal and providing a big surface for friction, they'll bear upon this bronze 932 and we'll have a good surface, small surface for friction, and also one that is better in the friction category, reducing friction, than this aluminum. So that's my next step. I'm going to build I'm going to build the main bearings out of this bronze, as I mentioned. What I think I'll do is chuck it up and drill and ream to 3/16 over for a length of the bronze sufficient to build 2 main bearings, and then I'll separate them from the stock. Of course, I'll have to turn them so that they'll fit these holes, and that I'll have to be careful, because if these holes are not the same size, then I'll have to do the largest one first. I think that's what I'll have to do first. We'll find out. So that's what's next. I'm going to create the main bearing hole. I'm going to center drill it. Then I'm going to drill it with a number 13, which is a 0.185, and then I'll ream it 3/16 over. That 0.185 will get me very close to 3/16, and the reamer will only have to take out about 2.5 thousandths. So that ought to give me a good finish. All right, it's looking good. I hit the diameter almost perfect. One of them won't fit, which is what I wanted, and one of them is a real snug fit. So it's somewhere between 0.499 plus and 0.500 minus. That's about as good as I can get. What I'm going to do next is do a little chamfering, and then part the first one off. There they are, the main bearings for those 2 engines. They turned out really well. They'll be a light press fit into the engine blocks. This makes me happy. I'm pressing the main bearing into the main bearing hole. I've got the engine block laying like that, and the main bearing you can see right here, and I've got these 2 blocks situated so that I can press the main bearing into the hole, and it's going in nicely. got it's pressed up against this surface here, and I want it to protrude by about 20 or 25 thousandths. So I'll have to come up with something that will allow it to do that. Some blocking. And I'll figure that out off camera. There we go. The bearings are pressed in about with about 20 thousandths protruding per side. This rule is 20 thousandths of an inch thick, and when I place it up there, I'm seeming to think that it's even with the bearing. However, you know, that's not critical. It's I just want it to protrude some in the event the main shaft slips back and forth this way. If it slips that way, then the eccentric will bear upon the protruding bearing instead of the aluminum surface. And if it slips the other way, then the flywheel will bear upon, or not the flywheel, but the crank disc will bear upon the bronze 932 bearing instead of bearing upon the aluminum engine block.